get started. Right on 12:05 almost. So, good afternoon, everyone. Looks like you guys are enjoying lunch, which is not Jimmy John's today. So, welcome to the talk. My name is Sagar. Most of you know me, but the talk that I'm going to be doing today is about a tool called Grabbit. This is basically an idea that we have been pursuing at Time Warner Cable at Denver for about 4 months or so, right? Like in fall we started this. As the tagline says over here, it's a fast content sync tool for AEM. So, on that note, what are we going to be talking about today? Most of it is going to be related to content. In CQ or AEM, content is basically, at the lowest level it's KCR nodes, and those kind of things. But at the AEM level, we have the CQ pages, we have DAM assets, videos, images, PDFs, documents, and whatnot. So we are going to be talking about those and basically content sync between two servers for those content at a large scale, so in production and so on. Before I go into start talking about it a bit of a disclaimer. This is going to be a bit of a technical talk, so I'll be going into some code level details later on, explaining it. But I'm going to be starting with the higher level information. So if you see something, at the start of a presentation or during our first initial slides that I do not explain, we'll most probably be getting to that as I go along and get to the end of the presentation today. So on that note, you know what this is, right? This is the interface that most of us are familiar with, especially the developers package manager. And you can see that normally we have the current process for us to use package managers to get our content updated or get content installed for the first time and so on. Maybe from some other server or maybe from your friends. What happens though when you have content which is big? This is not that big, but you really cannot have packages too big anyways, for just the process, the steps that you have to take today. You have to, if it's a remote server somewhere over VPN, you have to create that package over there, download it, which takes time, upload it to an instance, which takes time, install it to an instance, especially for something like DAM, it also takes time. So that is one thing that we know. Package manager, most of the developers have probably seen this. The second one, what RCP is really more on the DevOps or system admins or automation at the production level use case. Some of you may know what RCP is, but it stands for Remote Copy, provided by FileVault. It's open source, so you can look at it, what it does. It does basically the same thing, well, almost the same thing as Package Manager under the covers, but it's going to say that I want to sync content from source to destination, and you're going to give the paths, and it's going to do its thing, and hopefully it works. Going a little bit more, talking a little bit more about what RCP. I don't know if some of you may have looked at the actual source code for it. It's on GitHub, so it's Apache's open source one, so it's on GitHub. If you look at the source code, there are a couple of things that stand out, and one of the driving factors for us at Time Warner to actually think of something better, or not something better, but something different than what RCP or Package Manager do the content sync. Some of the prime use cases for us have been doing a backup from production down to some backup server. It can be gigabytes of data. We don't have that big of a data, content data, but I know that some, like Virginia project, for example, has pretty big data on their hands. So talking about some internal details of what RCP. First of all, if we talk about serialization or how they actually marshal their data to be sent or to be packaged up, it is primarily XML based. Historically, we know that XML is a bit verbose. There's a lot of things in there which most of them, it is widely popular, obviously, in enterprises, but also it has its downfalls when you have large content, especially being transmitted over the network, on long distances. That's number one. Number two is even more interesting, which is kind of related to the chatty implementation part that I have over here. But basically what that means is, if you look at it, it basically is going to, for every node that you want to sync from source to destination, it's going to do an HTTP request response over the network. So it's chatty in the sense of transport level details. For large content, hundreds and thousands of nodes, which you normally have, it is going to take time. It's going to bog down your complete process. So that is something that we did not like. So kind of rounding up to where we are going. Reliability, time, and monitoring. These were the three main things that we were seeing lacking in the current solutions that we had so far. Why do I say reliability? We use Jenkins on our side to basically do the automation for content syncs, right? There is obviously the tool can fail when doing the content sync, but it also fails in a manner that it doesn't really give you more about what to do next or what actually happened. It just says repository exception. Done. There is no monitoring or better control for you to actually look at what happened and act upon it in a way that is not restarting everything again. And also time, I talked about it a little bit. It does take time due to some of the factors that I mentioned. That is basically where Grabbit comes in. So we are trying to basically look at these three main things and say that, hey, can we do better? Is there any other option? Can we use some of the recent ways of doing things, and maybe not XML based serialization? Can we do something else? That's where it comes in. So you will see as I go along and talk about the details about Grabbit. It is a bit different than what you have seen so far, with the two tools that we talked about in CQ land specifically. But there's a big caveat for us because we want it to be usable and easy to install and such. If you look at it, it's really just another AEM application. So just as your project, you will upload it using package manager, will install it just normally. So what that will basically do is, say you have two instances, maybe over the network, wherever. If you install Grabbit onto both these two instances, Grabbit can act as a client or a server based on how you trigger the process call. So I will talk about how I do that later on, how it actually executes, but it is client-server based. A Grabbit installed on a CQ instance can act as a client type or a server type based on how you trigger the process on it. So let's start talking about some of the, start going a layer below and talk about serialization now. And I apologize, it looks like it's a bit hazy, but hopefully we get clouds again. So serialization. What do we have over here? As I said, XML was not what we were looking at. We were trying to see if there is something else. Google protobuf, or they are more widely known as Google Protocol buffers. They are one of the primary, or they are pretty new in that sense, not that old as XML, but this is an excerpt from Google's website directly, so I'm putting it over here, and let's see what it is. It is a way to serialize our data, and deserialize obviously later on to get back your actual data. But it is smaller, faster, and simpler than XML. If you look at their website, they actually say that it is up to 20 times faster than XML, but realistically, you will definitely see some significant improvements in there. So it may not be 20 times, it may be 10 times, but if you have large data that's being sent over the network, it's gonna add up to good, efficiency and better time required. So what are we going to be? Where are we using serialization? On our side. So let's take the same example as I mentioned before. We have two instances. One is acting as a server, one is acting as a client. Similar to what RCP, where you have the source and destination. And the client will say, hey, I want content. The client will talk to the server and say, hey, I want content for this particular path, whatever it may be. And the server, on the other hand, is going to start sending that back. And that's where the serialization comes into picture. When it's actually time to send data over the wire, It will do that serialization. Client will do the deserialization or unmarshalling on its side, and that's the place where it's used. And also, if anyone has any questions, please feel free to stop me anywhere, and we'll take those. On that note, any questions so far?
So, what is the protocol in which it's communicating with you?
It's still HTTP.
Still HTTP.
Yeah. The good thing about protocol buffers, though, is why is it faster, or at least one of the factors why is it faster? It converts everything in binaries. Right. So there is no verboseness of XML nodes, opening tag, closing tags, whatever. There's nothing like that. So you have that cut down completely. And there's also some compression that they put on top of that, which also helps. All right. Time to look at some code. This is an excerpt from the Grabbit code base. Immediately looking at it, I'm not sure if you can make out, but maybe this will help. We have something called as a node, properties, and property. What would this be? So in protocol buffers, you have something called as a proto message, very similar to your XML messages. And this is basically analogous to your schema, or the thing that defines what the data is going to look like. So you have, what are we going to be doing, or when we send data from server to client, we are going to have a bunch of nodes, and those bunch of nodes will have names, and they will have properties, right? At the lowest level, that's what JCR node is about. Even if the data that is formed when you store things in JCR is tree structure, and it is not normalized or whatever, but the node itself has good definition. There are rules around that. There's property rules, what kind of properties you can put. And that's basically what this is showing. We are basically saying that this is my data, that's how it's going to look like. There'll be a node, there'll be properties. Properties will be formed of multiple properties, or single properties. And each property can be a string, integer, or it can be a combination of those. It can be date, it can be long, and whatnot. All the JCR property types that we have. Here we have just string and integer because we are basically marshalling all the other types like dates and such into strings that we send it when we use the protocol buffer as that. So another interesting point at the top, you may see that there's in the second line says option Java package and option Java outer class name equal to node protos. So what actually protocol buffer does is it comes with a compiler, proto-C, proto-compiler is what they call it. And that basically takes this message and compiles a source code for you in the language that you deserve, or not deserve, that you want. So in our case, we have a JVM based, obviously. CQ is JVM based. We have all this code in Ruby, but Ruby plays nicely with Java. So that's what this is going to generate. This is going to generate Java source code for you to basically create these messages programmatically. What do we mean by that? This is a good example. This is again taken directly from the code base. This is the serialization routine for every node which is coming in. JCR node, it's going to take JCR node at a time, and it's going to return that message format. In our case, it's a node. One JCR node will marshal to one protocol buffer message node. And what's the point of the source code that it generates when you compile down to it? It basically creates APIs for you, in other words, getters and setters and builder factory methods to create these programmatically in a nice manner. That's what the first two lines over there are saying. It's going to say, create a new node builder, and it gives you the new builder instance that you can create, and you start populating that. So you do node builder.name equal to JCR node.path. Again, this is in Ruby, so you may see some Ruby-ness, functionalness in there, not too much. But similarly on the properties, you will get the properties builder, and then it will say that, hey, take the properties in the JCR node that's coming in, iterate over those, convert each property to your node property type or message, and build your properties that way. So that's what this is doing. If I go next, we talked about this one. So at this point, it's going to say, let's fill in the properties using the properties builder just above. And lastly, just return a new instance of this message. So if you have 100,000 nodes, this is going to be hit 100,000 times.
Can it not take from like a global properties where like it will inherit those properties from the node which is already being communicated with? Like like example in XML over RPC, right? You will have multiple instances where masking and unmasking happens.
Right.
So there is, you can specify like a global property in there where it will inherit all the client nodes over there. So what happens here?
So this is an example of what happens on our Grabbit server, right, which is going to send data to the client.
Okay.
The reason why this is going to happen for all the nodes is because we need to preserve the order of those nodes that are in the server side, because we need to store them on this, at the same order on the client side. In other words, if we have a path and there are like 50 nodes inside that, child nodes, you need to first store the base path or the parent path on the client side. So that's what this lets us do. And this is actually a good time to talk about the next thing, because I'll be getting to that. So as you were saying that you serialize stuff, node protos that, the Java source code that it generates, it lets you basically write that node to that output stream that you pass in. So in our case, we have the output stream which is going to go back to the client. And in the same way, on the client side, it's going to take an input stream which is coming from the server, parse the node back, and give it to you for you to use it again. So this is what I was going to get at with your question is we are basically doing a stream transfer in our case. So we are basically doing a recursive traversal on the server side for a particular path, and just going to send that in the same order as it was read, so as to not break anything on the client, especially for like Dan, where you can, or for like files, if you upload a file, some of you know that if you are uploading a file, so a node of NT file type, there are some rules around that parent should be there before the child is written, and so on and so forth. So we are basically trying to preserve the order. So you'll see an immediate stark difference over here as to the previous WhatRCP and such, where there is no chatting implementation. Client triggers something on the server once, and server just sends back the data. Of course, there is a risk if something goes wrong on the client side, you will be losing that data over the ether or something, but that's not going to harm anything on the client. So that's the risk that we are taking, I guess.
Okay.
Yeah.
Yeah, one more thing. Like right now within the serialization message which is sent across from the client to the server, what are the properties? How does it know that, okay, these properties are to be set? So for example, if you take like one particular video is supposed to be distributed in certain countries only, right? So like taking that example.
Okay.
So when it requests for a video link, right? When it requests for the content, which has to be come from a CDN or some kind of network. How does it know? Like, how will you configure the properties for that particular?
So that, so basically, any business logic you have, you can basically design your data that way.
Okay.
You can enforce a lot of things. This is actually the simplest example of how you can use protocol buffers. You can actually have nested messages if you want to enforce that inner messages has to be, can only be used if there is algorithm.
Right.
And things like that. So you can basically design your data in various different manners, and you can enforce those kind of rules over there.
Oh, okay.
Yeah, and a good example, most of us have know about this, so mentioning it. The Chrome, in your Chrome browser, you have the synchronization of bookmarks across devices. They use protocol buffers underneath, where they have C++ on one side, and because it's language agnostic, it can create source code for any language. It has C++ on one side, and maybe Android, it will have Java on the other side.
A point to that point is that Google themselves only support Java and
Yes.
C++. There's a lot of open source.
And Python.
Yes, Python as well. Since it's open source, though, other people have generated it for other
Yeah, but there are
languages.
several ports in other languages like Ruby, JavaScript, there is one, and all those kind of things, Scala. But yeah, base 3 supported by Google are Java, Python, and C++. All right, any more questions before we jump on to the next topic?
What's the performance hit on both JCRs if you're running it? Should it be something to be expected to run like at an off-peak time, or?
Really good point. Yes, so if we talk about the server, reading is cheap. So server is just going to read things and send it out. So that is really not that performance risky. But we will talk about what we do over here is basically do things in batches. 1,000 nodes, for example. So if you know, Adobe recommends things to be saved in thousands on the client side. So we actually have that on our control. That we can actually configure things that, hey, even if a stream is coming in from the server, just save 1,000 at a time and call the save method on the session so that it doesn't get, a performance hit. So on that note, talking about how things work in Grabbit a bit more, one more level down, we have the concept of Grabbit jobs. Of course, we have been kind of hinting the fact that Grabbit or the use case that we have is that of a batch processing use case. So we want to do things for large data, it may be hundreds and thousands of nodes. We want to make sure that we do things in batches, have good control over that, and so on. Of course, as I said, Grabbit is client and server based. Client is going to get new data from the server, and server is going to send data back to the client. How does that actually happen? And I mentioned that there are 2 flavors of Grabbit based on how you trigger things. It will be either a client or a server. So that basically takes us to the RESTful design or semantic design of how we are leaving things, how we are having convention of how things are triggered in Grabbit. So this is the example. Apologize if this is a bit faint, but this basically says client Grabbit configuration. The RESTful URI for that is /Grabbit/job, and you will see as I go forward, this is similar to, or this basically stays same. So we want to have the same semantic meaning, and if we get a put for this URL with something as the data, that becomes a client trigger. And we'll talk about server just next, but on the right-hand side, what we have is a configuration file for Grabbit to know what to do. So this is the client part, right? This is a JSON file. You may have got it already. But at the top, as the client doesn't know yet whom to talk to, we have some information at the top about the server, username and password, and host and port, and those kind of things. We assume that these to be correct. Otherwise, things will fail pretty easily.
Looks like a strong password.
Yeah. Well, this is localhost. And the other important piece over here is this path configurations array that we have, the JSON object array. This is very much similar to filters in packages. For creating a package, you have a bunch of filters. In our Grabbit use case, path is basically a filter. So you basically say that, hey client, basically get me 50 paths. And I'll give you the location, and I'll give you something else, which is workflow config ID, which I'll get to in a little bit. But that's basically how client knows what is the thing, what are the content paths that he wants to get from the server. This can be automated. It's a simple RESTful URI or HTTP, so curl command, UI, whatever. Anything can work in this case. Similarly, you'll be able to get it by now. How do we trigger the server aspect of Grabbit? Do a get at the same location and pass in a path, which basically says to the server at that point is, I don't know who actually asked me for this. I just got a URL, a request for this particular path. I'm just going to stream my data to it. So this will be, when we talk about Grabbit, 2 instances. Client will talk to the server with this get, and the server will send back the data. So same URL, keeping it a bit simple at that point. Any questions or clarifications on that note? It's pretty easy. Yeah, try to keep it simple.
Can you exclude nodes?
Yes, you can. That's a good point. So, yes, you can exclude nodes in a way that, say for example, you have a path /A/B, and you want to only take in some child nodes under that. So instead of blacklisting, like excluding, we actually do whitelist. So we say that just get these things and don't care about anything else. So you say that, there is a syntax for that. You can specify in the path. That's path string, but yeah, you can do that. On that note, I forgot to mention about workflow config IDs. So let's get to that. Some of you may know if we have some new content coming in on the DAM level, we have lots and lots of workflows around that which can trigger and can blow up your system if you don't control them normally. Even Adobe recommends to turn off the workflow bundles, I think, one, before you write something in. So we basically take in a little bit different approach, and this is what we have right now. But what we basically do is we say that this path is going to most probably be a DAM path. That's what we have right now, but it can be anything. There are these two workflow configs for that which you need to turn off. So we basically tell this to Grabbit client, and it's going to manage it for us. It's going to turn off these before writing or reading or even starting to write new content, and turn that back on as a part of the life cycle of the Grabbit job. And it will manage it for us automatically. If there's no reason to go to the bundles page, turn it off, turn it off, turn it on. Those kind of things.
So those paths should be paths to workflow models, correct?
No, these are the paths to launcher configs. So if you go to the launcher console in workflows, you have that launcher tab. That's basically what this maps to.
Okay.
So you disable those before you do anything with something that's going to trigger these, and re-enable them and then. All right. So if there are no more questions, let's jump into a small demo of basically seeing how it works. Hopefully the connection and everything will hold up for me. So as I said, right now, this is just 4 months old, so there is no fancy UI or anything that we have right now. It's a RESTful API, so you can do pretty much anything with it. What we currently have in Jenkins set up for automation is just a simple script that's going to trigger these jobs and later on going to monitor what's happening with them. I'll get to the monitoring piece later on, but this is just a teaser kind of. So what this is going to do is this is going to take in that configuration JSON file. I have just one path in it, and it's going to take it from the server, which is over VPN, somewhere in the Midwest, I think, and it's going to write it to our local host. Should be fairly quick. All right, so I'll explain what this is doing, but you can immediately say that it's sleeping and polling something, and it's done. So let's see what happened. The path is what we just got from a particular server, which was over VPN. Number of nodes that were in that path up to the end, the last child node or whatever, that were 122. The time taken was 4.5 seconds. You can look at this path. This is content where the admin checkout mocks. We can actually just for sanity's sakes, go back and look at our local host over here and look if that content is there, which it is. So this is a bunch of folders and a bunch of Groovy files in JCR. So it's fairly quick, but of course this was a demo data, so it's pretty small. But my main point to bring up over here was the fact that it was polling and it was monitoring in that sense. I'll talk about exactly what we do with it, but basically we have some things that are sent back for a particular path, like is it completed, is it failed, is it still running? If at this point it was completed, but if you go a little bit up, it's still running and the status is unknown. Nodes written is nothing, time taken, I don't know yet because it's not done yet. So that's the monitoring aspect, which is, we feel that has a lot of potential going forward. So that's our small demo. Not anything fancy, but any questions or clarifications about this?
So if you have a node that, let's say it's like a gallery of some sorts that points to several other nodes located somewhere else, they're not child nodes of that, they're stored maybe in the DAM or some other place. When you select that gallery, does it automatically, or can you have it automatically select anything that's associated with it?
So in short, right now it does not. And what we basically have done right now for that, to solve those kind of issues is, let me go back to the presentation real quick so that I can show. What we are basically saying is the person who is going to create this configuration file should make sure that all the references, if you may, are taken in. Of course, later on, there are lots of things that can be done to automate that or be intelligent enough to, on the server side, to say that, hey, you are getting this path, there are these five you should also get. But that is not in place right now. So we are putting that onus on the user who is going to create this file.
So if the weak reference is not brought over, it would throw a repository exception while it's doing the stream, correct?
Correct.
Well,
So
link reference won't do that.
link reference will do that as well,
Right.
but some other things will. And also, also if you have a path which, say for example, is pointing directly to one rendition in DAM, and if that is like the actual asset is not there on the client side, it's going to throw an exception because that's again something that we are right now pushing on the user who creates this configuration file. Like, hey, I just know to get and write data. The business logic you should take care of it. So
aside from moving new nodes from one instance to another, does it also update existing nodes as well?
it does, and I think that takes us to the next one. So actually, a little bit further when I talk about features of this new this framework that we're using, I'll get to that. So let's go to the next lower level of some of the 4 pieces of Grabbit. Here we are basically introducing the Spring framework called Spring Batch. Some of you may have actually worked with Spring frameworks before. It is a very well-known open source enterprise level Java application framework, JVM application framework. So you can basically do lots of things like MVC and big data and those kind of things really easily with Spring frameworks. This is just one of them, Spring Batch. Again, it is open source, so there are improvements for you to do if you want to. Again, a quote from the website, what they actually doubt this to be. A comprehensive batch framework for robust batch applications for enterprise systems. This is really the main thing. So our use case over here does fit into that a little bit. On the server side, you want to make sure that the stream of data is not bombarded back to the client, but it is done in batches. On the same note, on the client side, you want to make sure that client controls how it stores the data and so on. There are other features which we'll actually get to, and some of which we are already using, and some of which are really cool that we should definitely use. So what are those? First of all, chunk-based processing. Basically, batch processing is what we talked about before. Spring Batch lets you give you very easy way to basically manage that. Not just for JCR, it basically, any data, RDBMS or whatever it is, JSON files, text files, whatever it is, you can manage them in chunk-based processing. We'll look at how we exactly do that on our client side a little bit later, but one of the main features. Second one, declarative I/O. So what is this about? If you look at, if you think about what happens, say, on the server part of Grabbit, what do you think goes on? When it gets a request for sending something new back to the client, what it's going to do? It's going to do 3 main steps, right? It's going to take in the JCR nodes, read the JCR nodes from its instance. It's going to convert them to those protocol buffer messages that we said before, and then it's going to write back to the output stream in batches and so on. But those are the 3: reading, processing or converting, and writing. These are the 3 main things that the Grabbit server is going to do. Spring Batch, or in general Spring Beans, they're basically XML files. They give you a nice declarative way to basically specify what is going to happen when and control those and manage those. Again, we'll look at XML examples later on of how we exactly are doing it, but declarative I/O is another one. Start, stop, and restart. Of course, you would want to start your Grabbit job to do anything, but also stop and restart. So say, for example, there is one content path has like 200,000 nodes or whatever, and it's just taking a lot of time because you are over wireless on VPN across the country, and you really want to stop the job that is going on and not kill your instance while doing that, but do something else. So it provides a nice API to stop things that you started, so it will be done in a nice way to not corrupt your data and so on. Restart is another nice one. So a really nice use case for us is, like at least we have seen so far that why we think restart will be good, is if you look at like very low level JCR implementation of how things work, there are some exceptions which are really scary and you should never see them, but we do sometimes see them. And most of the times it is something like a deadlock exception for a thread, or concurrency or something like that exception. And you want to just basically say that, hey, this is an anomaly. I want to restart this chunk and make sure that this still gets done. That's again what you can do. We can control that, which is not possible right now in any other examples that we have. That's not what I want to do. That's what I want to do. All right, so retry and skip. Very similar to restart, but at a bit of a finer granular level. Retry is basically where, say you got a timeout exception when you were doing something over the network. There was a glitch. You switched off Wi-Fi, switched on to your Ethernet or something like that, and that particular thing broke because there was a timeout exception. At that point, you would want to retry that particular chunk or that particular process that was going on, and not again, kill your whole thing. Skip is another good thing. You can also skip based on whatever you want. So you, for example, you are getting some nodes back, say rep policy nodes, which are the user-related nodes that you have in CQ. And there are some rules, some stricter rules in CQ where you cannot just write rep policy nodes on the client side. You can say that, hey, if I get those kind of nodes, just don't do anything with it, just skip them. I will manage them later. This is just one example. There can be anything you can basically configure the policies that will trigger skip, retry, restart, and those kind of things. That's again a very powerful feature that we will have. I think we will have use of. Job processing statistics comes to your point where you said about updated content. So what this basically gives us is a way to look at historic data of what you did. Say, for example, there was a Grabbit sync done for 50 paths today, and you want to do the same thing next week, but you only want new things or updated things from them. So this basically gives us the power of looking at what happened today, and then maybe look at the time or the end time at that point, and just get the nodes that were either created or modified after that from the source. So yes, we can actually do that, and there is a alpha feature that we currently have in place for delta content, is what we call it. So this is a very powerful feature also. It's job processing statistics. So any questions or comments about this?
So is the skip mechanism a sort of filter, something to evaluate against, or how does it?
Yeah, it is kind of a filter mechanism.
Okay.
But it is much more, you can do, if you look at the API that they provide, it's so elaborate, and it's an API, so you can implement your own implementation for it, that pretty much anything can be done to skip something.
And also the ability to dry run. So currently it's either you're going or you can restart if something
Right.
wrong, right? Do you think that functionality will come in handy in the future of implementing something to perform a dry run before actually?
Most certainly it will, and that's a good point. We have not done anything like that yet, but I think a dry run would be good. Maybe, I don't know what the use case would be, or maybe for some content path, it may be useful to just say that I'm getting this damn content is everything I expect it to be, like the dependencies are there or something like that. That is certainly something that can be done.
Or also revert, see the content that came through and say, well, this, worked everything,
Yep.
or wrote something, so,
Yeah, so actually I didn't go into that because that's kind of an advanced feature, but these are just some of them. You can actually also roll back data if something goes wrong. So that's not something we have played around with yet, but it's something that you can do. Any more questions? You go so far. All right, so then to look at a little bit more, we have already talked about some of these pieces, but how do they fit in with Spring Batch? So this is a diagram from Spring Batch's website. This is what they call Spring Batch domain language, or main features, or main things in Spring Batch. So, to start off, we have the job repository at the end, which is the statistics storing thing, which will manage and store the historic data. And especially not just that, but also various steps. That's why you can see that the arrows are for everything in the list. That can be stored in there and you can look at. If we look at our use case on, say, the Grabbit server part, this is what basically it matches to on the server Grabbit job aspect. So we have a job for every content path, as I said, with that get URL. A job can have multiple steps, so one to n, and a step will have tasks in it, and that's where we have the reading, processing, and writing that we mentioned before. So reading will be reading JCR nodes from the server, processing will be converting it to the protocol buffer messages, writing will be writing the protocol buffer messages to the output stream. Very simple example of how our use case fits into these boxes. On the client side, things are a bit more complicated. Not too much, but time to look at an XML example. So as I mentioned, we have declarative I/O in Spring Batch or Spring in general. This is an example of a Spring Bean or an XML file, which defines what your job is going to look like. At the top, you see that this is a client job. So what happens is this instance is going to be executed for every path in the JSON configuration. In other words, if we have 50 paths that we want to get from the server, client is going to have 50 instances of this job, differentiated by the path and some other things like timestamp or something to have a unique ID for the job that you start. As I said, each job has multiple steps. The sum of these steps you can see over here. We have a step called client workflow off. That's the one which basically turns off these workflow config IDs or launcher configs that I mentioned in the JSON configuration. That's the step that basically performs that task. And this step is the main one, the client JCR nodes. This is the step where it is going to read the protocol buffer messages from the input stream that's coming in from the server. It's going to write it down to the, on its own JCR instance. It is going to do that every 1,000 nodes. So it's going to save the session every 1,000 nodes. This is the only thing that you have to do. Basically, you don't need any counter, don't need to manage that counter across multiple threads or anything like that. It is very easy to configure these kind of things. On the same note, we have something called as listeners. Traditionally, we know listeners say in JavaScript or whatever, listeners are basically going to listen for something and act upon that, when it happens. This one is a JCR nodes step execution listener. What it basically means is this is going to listen what happens in the step when it gets the input stream from the server. Why is it important? Say for example, you want to write back the status of what's going on at every step because it's doing it in thousands, right? So you need to know, is it doing it correctly? Did it fail somewhere in between or something like that? So this gives you a hook into the step that you currently want. So it basically is going to give you two methods, before step, after step. And just implement those methods and you're done. Log it out to your standard out, write it to database, send an email, whatever you want to do.
Does that also hook into start, stop, skip, retry?
Yes, it should most probably. I have not done anything with it, but it makes logical sense that I think that's where it will come into picture as a listener. called client batch job listener. So again, as we said, job is for every path on the client side. So this is going to have a method called before job, do something, after job, do something. So in this case, what we actually use the listener for a very important reason. The before job of our listener is the one that actually calls off to the server and gets the input stream back from the server, and then passes it along the steps to basically make use of it. So we make a really important use of the listener on the job level. Again, if you think about it, if you want to do something like this manually, you would, for one, have to maintain these things, and also improving these things will be a bit of a pain, and will take away from your actual business logic of getting data, JCR data. Any questions or clarifications around this? All right. So we are starting to come back a full circle. We had this slide at the start where we said we want these three things, or we thought that we could do better in reliability, time, and monitoring. So having looked at all these various features of serialization, Spring Batch, and whatnot, are we getting anywhere with this? Let's take a look. So reliability. In short, our client is multi-threaded. What that means is 50 paths coming in for client to execute and get the content from the server. Each path or each job is going to run in its own thread. There are several benefits of that, but first of all, you will see that as we are triggering this whole thing as an HTTP put, if you remember, we don't want that request to wait for 5 hours for something to come back. Making it concurrent basically spawns out these new threads, sends back the original control back to your servlet, and you get immediate response as soon as the things are concurrently started up. A very important thing that we also have a benefit of using concurrency. Of course, concurrency is a scary thing. You have to manage things a lot to make sure your code is thread safe and so on, but that's a good learning curve, so it's not a bad thing. Reliability, what it lets us do is basically separate out things that fail and separate out from the things that succeed. In other words, if you have 50 paths, 48 of them succeed, 2 of them fail. Unless these paths are overlapping, they won't be affected to each other. The other 48 ones will still succeed and you'll still have the data. Of course, there is a thing, there can be a question about integrity of data that's coming in. In other words, you always want to make sure that I get all the content back that I requested for. That's where the restart, retry, those kind of things come into picture. So if something fails, let's just restart that job. I don't want to just have the final report as something failed. I want everything succeeded. So restart is where we will have that capability of doing, making sure that the data integrity is in place. Quickly looking at the time aspect, we already talked about protocol buffers, how they are proven to be faster and cheaper over the wire. So protocol buffers along with stream of data. In other words, we don't have any chat implementation. So we do that by Spring Batch, where we manage things really nicely in batches and chunk-based processing and so on. And client-server implementation, at least if you compare it with the other options, and probably even other than, apart from that, it's going to lead to faster data transfer. So from our results so far, we have seen a range of 5 to 10 times better than any of the other options. Why do I have such a big range? The main reason for that being that things will be more towards 10 times better if you have data, 2 instances over network which are far from each other, because that's when the not having chat implementation and having stream of data is really going to kick in. On the other hand, if you have localhost 2 instances, you're not going to have that much of a performance benefit, time benefit and performance benefit of 10 times better. You'll probably see something on the lower range of 5 times. So, yeah, that's why we think it's a good start for something different. Lastly, coming to the monitoring aspect, I've been dealing that towards the end. We already looked at what in the demo of what we have. But we have a Grabbit status API, which is also RESTful, very similar to how we do other things with Grabbit. If you do a GET for Grabbit job ID.json, and ID will be something that is running on the client. You will know what that ID is. You don't have to look it up. The tool will make do it for you. When you do that, it's going to basically give you status for the thing that you started. This is an example of one of it. So we have get for Grabbit job a particular ID.json. We are seeing a JSON status for that. In this case, it is the end. That's why it's completed. It's not running anymore. Number of nodes written was 57,000 and something. Time taken is something in 3 seconds. And of course, we have the path. We have the start time, we have the end time, which is what we make use of later on if we want to do updated content things and those kind of things. This is an example of one job. If you have 50, there will be an array of 50 jobs. Then you can make use of JSON to whatever you want. You can update your UI with it. You can just log things in console like we did, whatever it is. So, a full circle over here. This is the, just wanted to mention this. This is the script that we use. I have the help section of it listed out over here. So, this is what we use in Jenkins right now. Monitoring Grabbit. You can start Grabbit from scratch, or you can start and monitor together. You can also specify how much to poll every 5 seconds, every 1 second, every whatever. Lots and lots of things. So that's the monitoring aspect. But if we think about it, there are lots of other things that we can actually do with the status. So that's what's next in our priority. Richer status API. So maybe we want to have some more granular level information about exactly maybe these many nodes out of these total nodes and things like that. All of these things are possible, and we think that these are important. Stop and restart, we already mentioned. There are good use cases for us based on the actual business need, like we wanted agility. Then let's implement restart in our use case, in our Grabbit job, and so on. Last but not the least, open sourcing. So there is a huge push on Time Warner Cable to actually make it open source. In fact, there is active steps being taken from the lawyers over there to, okay, this to be open source. And once it happens, hopefully it does soon, there'll be hopefully lots more what's next. And people will start using it, they'll have their own use cases, and things will be nice. So, I believe that's it. Thank you. And anyone has any more questions or comments?
Does it have to run on CQ?
Yes. Actually, maybe not, but I have not tested it in like any other JSON.
So I'm thinking at like on the Sling Launchpad instance. So let's say, because I'm doing, like say, my use case I could have is I want to back up the system. I don't need it necessarily back up onto a full-blown CQ system. So Sling Launchpad might be a good possibility for JCR, Felix, and all that good stuff.
Certainly. But yeah, because the use, it's working at JCR level, and it's using Sling APIs or resource servlets and so on, it should not be difficult to do that, but right now it won't work. But take open source.
Okay.
Kind of related to that, are there actually any minimum requirements for CQ version? Ruby?
Oh yeah, sorry, I didn't mention that. It is currently 5.6.1 that we are testing it with. In fact, in the not so distant future, we are going to be testing it in AEM 6 also, because we're already looking at upgrading to AEM 6 at time one. So, yeah.
Does it only support HTTP, or does it do HTTPS as well?
It currently supports HTTP only. The client that we're using, Apache client, it can support HTTPS, but it is not implemented. And again, as I said, the data backup and those kind of things are already happening in the VPN. So current use case can call for HTTPS.